let's finish up the heat unit talking about thermodynamics, talking about the study of heat and its relationship to mechanical and other types of energy, so electric and so forth. So what we're looking at here is what we call a heat engine. All of these guys do is convert heat into mechanical energy. So these are actually kind of cool little devices. They basically work just by air. They are a piston, so they are a column with a piston mounted in them with compressed air underneath. You place a weight on top. You then apply heat to the bottom, and that expands the air molecules because, as we've talked about in previous videos, that gets the air molecules having more energy, and so they move more. By moving more, they expand that space and push the piston up, doing work. So they're converting that heat energy into mechanical energy doing work. So thermodynamics have a couple of laws. We're just going to look at two of them. There are more laws if you were taking a full-on physics class, but we're just going to talk about the two that generally apply to everyday life. So the first one is when heat flows to or from a system, the system gains or loses an amount of heat equal to the amount of heat transferred. Wow, that's a lot. So what do we mean? Energy can neither be created nor destroyed. So you can't just get free energy, is what the first law of thermodynamics means. You have to get that energy from somewhere, and it can't disappear. It has to go somewhere. So when you got heat coming in, it has to be transferred out. So the same amount that comes in has to equal the same amount that goes out, is what we're saying here. The second law of thermodynamics is related to something we've talked about in a couple of other videos, that heat never spontaneously flows from a cold substance to a hot substance. So it never goes from cold to hot. So it has to go the other direction. On its own, it's going to flow hot to cold. And so think about it like this. In summer, if you aren't going to be using your air conditioning, or if you're not going to keep your house all closed up, I guess that would be a better way to say it. During the summer, your heat from outside is going to flow in to the house, right? The hot air is always going to try and come in, which is why you constantly have to have your air conditioning kick back on to cool everything back down. And the opposite's true in the winter. In the winter, the heat is constantly trying to move out of the house because it's hot inside and cold outside. So the heat's constantly trying to move out. And because of that, we have to regularly turn our heating back on so that it warms back up, so that then the heat can move back out. The thing is that every time that we use the energy, some of it is going to be degraded or lost to friction. So we're always going to lose some of it, no matter what happens, whether it's that it's moving, like up here in the example of heat moving in the house, or if we're using it to do work, like in a machine. So heat can only do the cold to hot when work is done on the system or by adding energy from another source. So as I've mentioned in another video, you can get heat to flow from cold to hot if you apply work, if you apply energy. So like with a refrigerator, if you apply electrical energy, then you can get that interior of the refrigerator to be cold compared to the outside, but you have to continually supply new energy to do that. And it's never 100% efficient. You're always going to lose some of that to heat. So great examples to this would be a refrigerator, an air conditioner, heat pump, all of these things that we use to reverse the flow of heat, but they're always going to lose energy as heat when they do it. All right, that is the end of the heat section. If you have any questions, feel free to contact me about any of the material.